Good morning, my dear students. This discussion is still part of geometric sequence, and this is finding the sum of infinite geometric series. Yes, you heard it right, class. Sum of infinite geometric series. Now, probably you're wondering, class, infinite, but do have a sum. So here's the thing, class. Not all infinite geometric series do have a sum. Okay. Now let me present to you first the formula for infinite geometric series. That is given by a sub 1 all over 1 minus r, provided that this one only works in infinite geometric series and also r must not be less than 1, or the absolute value of r or common ratio class must be less than 1, or it can also be written as the common ratio of infinite geometric series must be greater than -1 but less than 1. Now, I have here three infinite geometric series class, and I'm going to identify and discuss to you how to identify if a given infinite geometric series do have a sum. Again, the condition there or the restriction there, the common ratio of infinite geometric series must be less than 1. The absolute value of the common ratio must be less than 1. Let's have 6, 2, then 2/3. Let's have the first example. 6 plus 2 plus 2/3 plus dot 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 or ellipses. The given sequence is 6, 2, then 2/3. So taking the second term divided by the first term, it is 2 over 6, which is 1/3. Or you can have 2/3, the third term divided by the second, which is 2/3 divided by 2, which is equal to 2/3 times reciprocal of this, 1/2. So it is still 1/3. Now, let's see in the condition. So is 1/3 less than 1? Yes. We all know, class, that 1/3 is less than 1. So therefore, class, this particular sequence has a sum. Applying the formula a sub infinity, no, so in number 1, applying the formula s sub infinity is equal to a sub 1 is equal all over 1 minus r. So the first term in the given problem is 6 all over 1 minus the common ratio in number 2 is 1/3. So 1 minus 1/3. So this will be 6 all over 1 minus 1/3 is 2/3. So proceed to multiplication by getting the reciprocal of this. So this will be 6 times 3 halves. Cancel this. This will be 3. This will be 1. 3 times 3 is 9. So therefore, this is now the sum of the infinite geometric series. Let's have the second. 2 plus 4 plus 8 plus 16. A sub 2 divided by a sub 1 is 4 divided by 2, which is equal to 2. Then a sub 3, a sub 2 is equal to 8 divided by 4, which is obviously still 2. So with this, class, in number 2, the common ratio here is positive 2. And take note, class, 2 is greater than 1, which means this particular sequence or series doesn't have a sum. So therefore, the sum cannot be identified. Number 3. 27 over 8, 9 fourths, then 3 halves, and ellipses. So, number 3, second term divided by the first term, it is equal to 9 fourths divided by 27 over 8, which is equal to 9 fourths times 8 over 27. Cancel, 3, cancel, 2, so it is equal to 2 thirds. So that's the ratio. Let's have the third term divided by second term. So we have here 3 halves divided by 9 fourths. So this will be 3 halves times 4 over 9. Cancel, this will be 3. Cancel, this will be 2. Still, the common ratio here is 2 thirds. And we all know 2 thirds is less than 1. So therefore, number 3 has a sum. So in number 3, the given sequence is 27 over 8, 9 fourths, 3 halves. So let's apply the formula. S of infinity is equal to a sub 1 all over 1 minus r. So the first term in the given is 27 over 8 all over 1 minus the common ratio, which is 2 thirds. So this will be 27 over 8 all over the reciprocal, 1 minus 2 thirds. This will be 3 over 3 minus 2 thirds. It will be 1 third. So get the reciprocal of it. This will be 27 over 8 times reciprocal is 3. No terms can be cancelled, so we'll just multiply it numerator to numerator, denominator to denominator. 27 times 3 is 81. Then this will be 8. So the sum now is 81 over 8. So that is how you identify class, how to get or identify the sum of infinite geometric series. Again, not all infinite geometric series do have a sum. You should always remember that the common ratio must be less than 1, or absolute value of common ratio must be less than 1, or it can also be r, or the common ratio must be greater than -1 but less than 1. Thank you for listening and watching the discussion for today.